Okay, just a few more problems with the double angle and the half angle trig identity. So again, people that teach reference angles wouldn't know this because they just live in quadrant 1. So obviously you guys know where 90, another 30 degrees, you can figure out the cosine. But say we want to use it just using the double angle and kind of proving it that way. So again, I could split this into something that equals 120 degrees, all right? And use my double angle formula. Now this is your alpha or your x. So in the formula, this is what you sub into the angle. For cosine, so again, there's varied forms for cosine. I'm going to use cosine squared x minus sine squared x for this example, but there's, 2 cosine squared x minus 1 minus 2 sine squared x. So there's other versions of this. I'm going to just use this one. All right, so here's my alpha. All right, so I get cosine squared of 60 degrees minus sine squared of 60 degrees. So again, people who do reference angles would only know like their 30, 60s, 45s. So I would sub in, so again, on a 60-degree angle, right, this would be what, half square root of 3 over 2. All right, so that would be a half squared minus square root of 3 over 2 squared. That would be a fourth minus, what's that going to be, 3/4, is that right? So I get a negative 2/4, which is a negative half. Now again, those of us that know the unit circle, obviously we can see that this is a negative half, positive square root of 3 over 2. So we could get it that way, but that's how you could use the double angle trig identity if I asked you to verify it or something like that. All right, let's look at another half angle one. All right, so we did one already. Let's look at another one. And sorry for the rustling of papers here. So say I wanted you to find the exact value, which is kind of what we always say in trig, of say cosine of 75 degrees. Again, not on the unit circle, so that kind of doesn't help. Now, as far as could you use other things? Absolutely. So you might look at this and be like, I think I'm going to do cosine of 45 degrees plus 30 degrees, all right? So cosine alpha plus beta. So then you'd look at your trig identity sheet, and that would be one of those, like cosine, cosine, sine, sines, or cosine, sines, sine, cosines, one of those trig identities, and you could use that, all right? Otherwise, you could look at that and say, okay, well, if I double that, then that's on the unit circle. So this is actually the half angle formula because you have to double it so that you can take half of it. So your alpha is right there. All right, so say we're going to use this trig identity instead. And again, on a test, if I don't tell you, either one is fine. So plus or minus, again, just means I don't know if it's going to be positive or negative. My alpha is 150 degrees over 2. All right, I get plus or minus, and I look at my unit circle because that would be something that's on the unit circle. Alrighty, so now I need to get a common denominator, which again is 2 over 2. So I'll just do that over there, plus or minus. I get what? 2 minus the square root of 3 all over 2 all over another 2. So this is why in algebra we study, complex fractions, so we can do this. There's an invisible 1 under there, so I'm going to just go ahead and multiply by the reciprocal and deal with my complex fraction here. So distributing the 1 to both of those isn't going to do anything. My denominator becomes a 4 now, right? And so then I can square root and get 2 minus, and you typically get a root under a root. That's pretty normal in these, and the square root of 4 is 2. Now, at this point, I need to decide this, all right? So this is my choice, all right? So this is what I was talking about earlier. You have to decide the sign based on this guy, all right? So 75 degrees, here's my 45. So 75 is somewhere around here. Obviously, it's positive, positive. Do not look at 150, all right? Because 150 is just what I used in the formula. It's not my original angle. My original angle is 75 degrees, which is definitely positive. Where if you look at 150, the cosine there is negative. So you want to be very, very careful here. So my final answer is positive, and it's 2 minus radical 3 all over over 2, and it is definitely positive. So that is my final answer to that problem. All right, let's see if there's one more I have time for. Let's look at this one quick. All right, the last one here is, say, tangent of negative 15 degrees. Again, not on the unit circle. So sometimes students mix up the double angle and the half angle, but when you're using the half angle, you actually have to double your angle so you can take half of that. And I know that might seem confusing, but when you look over here and you write it this way, you can see that this is half of an angle. So in this case, my alpha is actually a negative 30 degrees. All right. So the nice thing about tangent is, remember, as long as you do your angles right in here, you know, you don't have to worry about the sign. The sign at the end is going to be exactly what it's supposed to be. So I get 1 minus cosine of what, negative 30 degrees all over sine of a negative 30 degrees. All right, and so I'm going to come over here. So again, those are on the unit circle, right? If you look at negative 30 degrees, we're right down there, which is what, square root of 3 over 2 and the negative half, right? So I get 1 minus square root of 3 all over 2 over a negative half. All right, so again, to deal with division of fractions, you multiply by the reciprocal. So I am going to go ahead and cross this off and instead multiply by a negative 2. Now just make sure you multiply all of it by a negative 2. So I'm going to distribute that, and I get a negative 2 minus, and if you want to put a 1 under there, you can. Numbers with numbers, radicals with radicals. So again, if I can come over here to help you out. Okay, my negatives are going to cancel, and I'm going to get a positive, and then do you see how that 2 would cancel that 2? All right, so I get positive radical 3. All right, and that is the exact value of tangent of negative 15 degrees. Again, if you want to check your answer, you could convert this to a decimal, and you could do this in degrees on your calculator. If the two decimals match, you did it right. If they didn't, you did it wrong.